Hello. Today I would like to talk about one of the main topics in the field of knowledge discovery in databases, KDD, outlier detection. I chose paper published in Proceeding of International Conference on Management of Data. And what is actually outlier? I think when you are looking in this picture, you might get an idea. Yes, we will talk about this red fish. And as examples, we have red apple instead of green apples, this funny emoji and a crowd of sad people, and this so far point this point so far of other set of points. Um, in the study of databases, finding the outliers can be more interesting than the finding common patterns of objects in dataset. Earlier works in outlier detection had regarded being an outlier as a binary property. In this paper, authors presented a regional method assign each object a degree of being outlier. This degree is called the local outlier factor. LOF or LOF. LOF is a measure of an object isolation with respect to the surrounding neighborhood. Using real-world datasets, authors demonstrated that LOF can be used to find local outliers. Earlier studies in KDD focused on finding patterns applicable to a considerable portion of objects in a dataset. Finding anomalies and outliers had not received enough attention in the KDD community before this paper was published. The most studies considering being an outlier as a binary property. That is, either an object in the dataset is an outlier or not. That is binary properties. But for many applications, we have the situation is more complex than binary. And it becomes more meaningful to assign to each object a degree being of outlier. Look at this slide. One of the types earlier algorithms is clustering algorithms. Clustering algorithms can help to detect some outliers. How? This is three sets of points, which names clusters. And some abnormal data, yellow points, is it is called noise in the clustering algorithms language. But also these algorithms have some problems. For example, outliers in these algorithms are side effects. Primary task of the algorithm is clustering some normal data in dataset. And actually, in these algorithms, outlier being outlier is a binary property. We haven't degree of being outlier. Another problem is some error algorithms for view of some algorithms, some points, okay, I will show you. Look at this picture. We have point 0.01. This is called global outlier. Global outliers, it's actually good, and many of our algorithms can define this, and it's not some problems, but we have a point of 2, and in this picture we have two clusters, C1 and C2. C2 is really high density. Between 2 points in cluster C2, we have really low distance. But in cluster C1, distance between some points, it's really big. And it's elementary that set 0.1 is a global outlier because the distance between 0.1 and both of clusters so large. But what about 0.2? The human perspective, easy can to say 0.2 is outlier 2, but 0.2 is local outlier. What does it mean? 0.2 is outlier for cluster C2, and it's elementary. But for error algorithms detection outliers, 0.2 it's not an outlier because this distance between 0.2 and another point in cluster C2 is actually equal, like the distance between each points in cluster C1, but C1 is cluster and he hasn't another outliers. And that is the problem why we need some degree values for outliers, how far the outliers lay than some clusters. Another example, here we have 4 clusters and some global outliers. These points are really far from all the clusters, and some local outliers like this, or this, and these points. And we can see for cluster C2, these points are local outliers. And this distance is less than this distance. What's mean the degree being an outlier of this point is greater than this point. Now we can say about density metric, because algorithm in this article is density based. We can say about called k distance. K distance is some characteristic for point, which means, for example, k is equal 3. It means some area neighborhood of point O that in the area we have only 3 another points, 1, 2, and 3. And more, we we have another characteristic is reach distance. What is reach distance? Reaching distance. It's maximum of k distance or distance between some points. In this example, we have reach distance for point P1, P10. It's equal the k distance of point O. But P2 is laying out of k distance point O, and reach distance of P2 is equal distance between these 2 points. K distance and reaching distance is very important denotions and donations in this theory. And following we showed formal definition for from k distance. Need more explanations. Actually, the LOF, it's a parametrical characteristic, one parametrical characteristic. It's one parameter. It's called mean PTS. Mean PTS is parameters specifying a minimum number of objects. Looks like we have here formula for reach distance between points P and Q. Mean PTS and reach distance we needed to get some general upper and lower bounds for LOF to get used LOF. LOF for elements of cluster is equal to 1, and when they have some outlier, outlier has values of LOF, for example, 1.2, 1.4, and another variance. And let's go show how LOF algorithm works in real data sets. Look, we have two clusters. Clusters of points with normal distribution and points another distribution. LOF, our algorithm to detection outliers, has only 8 errors, these points. It's errors because they are too close to clusters, but our algorithm decided they are outliers. And in this right picture, we can see k-distance of all points, and we can see how outliers circles greater than cluster circles. And why we do all of this? I can demonstrate it with real data sets. This is soccer league with data's players, how many games they are played, they played, and how many they scored, and also position when he played, where he played. After using our algorithm, we can have some values of outlier factor. Look at rank 1. Outlier factor equal is 1.87. This player, Michael Pritz. Michael Pritz is the strongest outlier in this table. He was top scorer in the league. And our algorithm get us our algorithm has gotten another interesting good result. It's this rank 3 person. He has 1.67 outlier factor, but what's interesting, he is a goalie or goalkeeper, and this is the only one goalkeeper who has scored at least once, and more, he scored 7 times in league. And this so interesting outlier of this data. Let's get the conclusions. What's novel? Now we have some good algorithm to local outlier detection, and LOF is giving us a degree of isolation relative to neighborhood. And also, this method has many uses, in particular the tracking of suspicious activities and fraud. It's so important in our modern life. Thank you for your attention. Goodbye.